EUROPUR and EUROMOULDERS for this opportunity of presenting FreeFOAM to you this afternoon. What I'm hoping for is that you'll take away with you at least an insight to the project and an understanding of the hoped-for benefits that this project is trying to achieve. So let's take a look at FreeFOAM. That's up to me. Different systems. Okay. FreeFOAM, it's about trying to develop an innovative method for isocyanate encapsulation which will be an improvement to today's technology on PU foam formulation. It's being sponsored by the European Commission under their FP7 Framework Programme. And this is a wide programme of projects that the EU are supporting for the benefit mainly of SMEs. And of course SMEs are important because as you look at the makeup of industrial base within Europe and probably wider than that, then 90% of organisations and companies will probably be described as SMEs. FreeFOAM in particular, it's a project which is planned to run probably for about 36 months. We're about 12 months, 14 months of the way through that project at the moment, so it's due to end in 2016. The programme is devoted to trying to help the competitiveness of SMEs. Typically, what we're looking at is developing technical solutions where amongst SMEs they find these as common problems. When you look at the plastics industry within Europe, it's a huge organisation of different companies at different levels, and yet many of them face very, very similar challenges. So we have the support of the European Commission under their FP7 Framework Programme for projects, which very shortly is going to be superseded by a new set of framework parameters where the EU are looking to possibly spend up to 80 billion euros in supporting projects of this nature up to 2020. I mentioned earlier that I was pleased to present the project on the basis of the consortium. There are 9 organisations which have come together in order to try and achieve the results of FreeFOAM. Those organisations have a wide range of different experiences that they can bring to the project and different knowledge bases. In no particular order, I'll just give you a quick insight as to who those organisations are. We mentioned the British Furniture Manufacturers Association. Here is an association, a trade organisation for UK furniture manufacturers, but not exclusively. The BFM is happy to work in a much wider arena, hence its involvement in Project FreeFOAM for the benefit of the wider industry. The Slovenia Wood Industry Cluster, this is a combining companies and institutions from the forestry, wood processing and furniture sector. We have the Association of Chemical and Pharmaceutical Industry of the Slovak Republic. This is a voluntary organisation, works in the field of chemistry and pharmacy. Cosmetic Valley is probably an organisation you may well have heard, very large, 550 companies that it represents in the industry of perfumery and cosmetics. An organisation, EUROPUR, these are actually PU foam manufacturers. They have a lot of experience of producing the product as we understand it to be today. Tagra, they are a technology-based company and bring to the project a wide range of initiatives where they can be developed to produce sort of proprietary and custom-tailored technical solutions, predominantly in the health and welfare industries. C10 is a technical research association based in Spain, and it's a centre for furniture and wood development of products. Inspiralia, again a Spanish organisation, based on a focus towards research and the development and innovation of services to companies. Polymer Expert, Polymer Expert, innovative research, a wide range of experience, everything to do with materials and in particular with polymers. So that's the consortium that have come together, been working together with a good relationship over 14 months in order to move the project forward. So let's have a look at the aim of the FreeFOAM project. It's to develop a process that will achieve microencapsulation of isocyanate. Why would we want to do such a thing? The reason is that we believe that that could well lead to open up a new way of polyurethane processing. At the heart of the project, it's trying to create a unique, homogeneous reactive mixture for PUR foaming processes where we physically separate the reactant from the reactant process such that we can manage the control and the release of isocyanate in the PUR foaming process. As we know, or many of us will know, mixing of isocyanate and polyol together without reaction is not part of the current process that you have as your technology at the moment. We want to be able to control the breakage of the capsules, the encapsulated isocyanate, such that we can manage the performance of that, both in terms of time, as it is released into the mix, and it may well give the opportunity to add some functionalisation that is not necessarily available today, where we can look at the properties that it actually develops from the mixing process. We also believe that there's an opportunity to minimise the amount of waste that can be produced from the process, and this can be due to bad cell homogeneity and product density as a consequence of bad mixing process. So in its most basic terms, let's have a look at what we're trying to achieve. Trying to find, there we go. At the moment, if you can imagine a situation where we have isocyanate, either MDI or TDI, and what we're trying to do is to put it within a shell of a dissimilar material, a polyol. And by doing that, we can then decide as to how we manage the breakage of that shell around the isocyanate to time the release of it in the mixing program. Okay. Let me try and run through you in simplified form the basis of the process. Starting at item 1, then we're introducing the isocyanate with polymer and putting that into an organic solvent mixture. We can then mix that up together. Once we have the mix, we then introduce it to a surfactant. You won't be surprised, but the purpose of the surfactant is to do what surfactants do, and it's to try and ensure that there is separation of the individual particles such that the polymer can actually coat the particles of the isocyanate. We do that again through a mixing process. What we now need to do is to start to remove the organic solvent material that we have, because that is not wanted, so that can evaporate from the solution either naturally, or we can introduce ways in which we can help that process along. Once we've taken out the solvent mixture from that, what we then want to do is to capture the individual particles that we have that are encapsulated by the polymer. So what we need to do, we can use a process of centrifusion. Other possibilities are available, but they're still currently under development. So we can now, through centrifusion, we can get the particles away from the surfactants. Once we've got the particles, they then can go through a freeze-drying process to make sure that we take off any excess water that may be present, and then we will end up with a powder. The powder will comprise of isocyanate, which is encapsulated in a polymer shell. So now we have one ingredient, a very important ingredient, if you actually want to achieve polyurethane foaming. And what we're trying to present here is that you can take the ingredients of the isocyanate, we have the polyol, we're going to mix it with urethane, and we're going to now introduce it into the manufacturing process, and we need to break down the shell that surrounds the isocyanate. Now there's a number of ways in which this could also be done, and they are currently under development and review. But one of the ways of doing it is, for example, you could stir the mixture in the process of delivering it into the mould. That will break up the shell that sits around the isocyanate. Alternatively, you may well find that if you push the material through pressure, which is part of a normal PU foaming process, then you can get a shear situation where that will break down the shell that's sitting around the isocyanate. However we achieve that, what we're going to now be able to do is to release the isocyanate into the PU mixture and start the reactive process of producing polyurethane foam. Okay. We have some expected results, even at this stage in the project. We believe that we will be able to develop an innovative method for isocyanate encapsulation. We believe that we'll understand a lot more about surfactant agents and how they can be used in a positive way to increase the emulsion capability and encapsulation efficiency of the process, hence working towards the reduction of waste as part of our objectives. That it could well take us to achieving an innovative PUR foam formulation based on polyos and micro-encapsulated isocyanate. And we believe it also produces an innovative approach to PUR foaming compared to that which we work with and have done today for many years. We've talked about the creating of a new microencapsulation method. We believe that the project has identified, albeit there are some alternatives that are still under review, but the principles of where we started and where we want to end up, we believe that the project results are confirming that we are on that road. If we can create this new product, then we also believe that in the forming of the shell around the isocyanate, here is an opportunity to actually introduce some functionalisation of that shell. For example, we may well be able to manage things like the flexibility of the resultant product, the antibacterial properties that the products might have or the finished foam might have. So a lot of work will be done to try and achieve additional results as a result of the process, because we have this shell and it offers an opportunity not for it just to be discarded, but to actually help in producing better properties to the foam. In terms of its commercial potentiality, we believe it won't just be necessarily beneficial to PUR foam manufacture, but it can also be used as a technology and a process to help take forward some of the understanding that we have at the moment about the manufacturing techniques that we use in the cosmetic, pharmaceutical and footwear industry, and there are many more areas in which we hope that we can take this project forward. I'd like to thank you for your attention. I do hope that it's at least been of interest. We have outside the doors on your way out, we've got a summary leaflet about Project FreeFOAM. It's on the website. You'll see the link to the website that's on the FreeFOAM leaflet. We update it regularly with the work of the group. We do hope that you'll take a look at it. We are moving forward, and I think, and the consortium believes, that we are heading towards an exciting time of being able to come up with a new and innovative process to help the industry. Thank you very much for your time.